Welcome to today's class. My name is Mazi Udaji Kingsley, and today we'll be talking more on linear scale factor. If you look at the example, it says the linear scale factor of two similar shapes is 4:7. If the area of the bigger shape is 392 centimeters square, find the area of the smaller shape. So, and we know the formula already. I'm doing in the classroom. Either linear factor of small or linear factor of big over small or small over big, whichever one. But for today, we are going to talk about linear factor and then area factor. So we are going to stop our, this is the two formulas we are going to be using. If you do that, you see we are doing small over big, which is 4/7. And we are asked to find the area of the smaller shape, which we don't know. We use the variable x to represent it. And then the area of the big shape, which is 392. But we can't do anything here because this is a linear factor. And we have to convert a linear factor. Converting a linear factor to an area factor, we have to square it. So that's why we have to square 4/7. And if we square 4/7, 4 squared is 16, 7 squared is 49. That brings us here. And then we have to cross multiply. So 49 multiplied by x and 16 multiplied by 392. And if you do that, you have this. We divide both sides by 49. If we divide both sides by 49, 49 can divide 392 totally. And if you do that, you see that it is 16 times 8. And 16 times 8 will be giving us 128 centimeters square, which is the required area of the smaller shape. And then we will have to move on to the second one. So which is two similar cylindrical objects. And what are cylindrical objects? In the classroom, we identify some cylindrical objects. One of them is the pole we use in hanging the curtains in the classroom, the suspender, the pole that suspends the fan from the ceiling. And so we are comparing two of those cylindrical objects. I will say the scale factor is 2/3. And they say should we find the ratio of their volumes. So of course, you know the formula now, linear factor and then volume factor. And then for you to move a linear factor to a volume factor, you have to cube. So that's why you see we are cubing the linear factor. And if you cube 2, you get 8. If you cube 3, we get 27. This is it. And then the volume ratio for the cylindrical shapes are 8:27. Do you understand this? Okay, do have a nice day. Please go down and do the activity below and then submit for marking. Thank you.